Hello boys and girls, welcome back to my channel OneMentor, and here we are with our second video on topic parallax in observing star. So we are going to start with parallax in observing the stars. So in this topic we are going to talk about the parallax from chapter 2, units and measurement. So what I want to do in this video is to explain what parallax actually is and try to visualize that what parallax actually is, and then try to visualize what the parallax would be like in the given context of observing relatively nearby stars. And then in the next video we are going to think about how we can use the parallax of nearby star to figure out how far they actually are away from us. So parallax really is just the apparent change in the position of something based on a different line of sight. So when you see that while you are looking out of a car, you're gonna see, depending on how far different things are from you, it looks like they're moving relatively to each other. Right now I'm looking at my computer monitor, and if I move my head around or shake my head around, it looks like the wall behind the computer monitor is moving relative to the computer monitor. We have all experienced this. But let's think about what parallax means when looking at stars. So let me draw the sun over here. And obviously none of this is drawn to scale. So let me draw the sun over here, and let me draw the earth at some point in its orbit around the sun. And we are to pretend that we are looking above from the solar system, so the earth will be rotating in the direction right over here, in this direction right over here. And let's say the star that we care about is right over here. The star that we care about is right over here. I will see not clearly drawn to the scale. So what we are going to do is we are going to wait to the point in the year. So point in our orbit around the earth, so right at dawn. So we are sitting right here on the surface of the earth. Simplify the things, we are on the equator, and let's say that this stars roughly in the plane of our solar system. So we are sitting right here on the equator. You can see that the small one is our equator, and then right at dawn, right when the first light of the sun begins to reach, right now the sun is lighting up this side a weird. So right when the first light of the sun is reaching me, I am looking straight up. So if I look straight up right when the first light of the sun is reaching me, and I look straight up like that, I will be looking in that direction. So now let's say that direction that I'm looking at is this direction right over here. So let's say this let me make it clear. This is the separate part of the diagram here. This is the separate part of the, maybe I'll do it over here. So if I'm in the night sky, looks like this. The night sky looks like this. The sun is just beginning to rise on the horizon. If I look straight up, I'm looking in the direction, in this direction. So where would this star be relative to the straight up? Well, straight up going to be like that. The sun is right the way I drew it right here, right to my left. So straight up is just like the sun is just coming over the horizon. This star right here, that apparent position, the star up going into the some angle or a grade to the left, to straight up, it's going to be right over there. So the star moved that big relatively to the entire the vision, but you get the idea. Okay, a little bit smaller than other thing, and looks just like that. So there is some going to be angle here, and this angle, whatever it is, and let us call just as theta, that's going to be the same angle as this. About I'm talking about the angle, talking about if you measure from one side of the horizon to the other side of the horizon, you are essentially looking half away around the earth. That would be 180 degrees. So you can measure what that angle is over here, right over here. And now let's say we waited 6 months. 6 months, what's going to happen? 6 months we are going to be on this side of the, we are gonna be this side of the sun. Our distance will be assuming relatively confident at 1 astronomical unit. Now what happens if we wait? Remember, the earth is rotating like this. The earth is rotating like this. So right at sunset, right when the last glimpse of the sun has just gone away, because you can remember right now the sun is illuminating this side of the sphere, this side. So first sitting, we are right at the equator, right over there. Right when the sun is just setting, we look straight up. Like the sun is just setting, we look straight up. We look the same straight up. So 6 months later, when we look straight up, where is the star relative to straight up? Well, now the star will be to the right. It will be in the direction. So in this is our field of vision 6 months later. Now the sun is setting all the way to the right. All the way to the right of the right horizon. And if we look straight up, this star now is going to be to the right of the straight up. So what just happened here? Well, looks like relative to straight up, and we are looking at the exact kind of position of the earth, looking in the same straight shore that we are picking times of the year and times of day. We are straight up in the same direction. We are looking the same direction of the universe. It looks like that the position of that star has actually shifted. If this was the let's say this is the middle of the summer and this is the middle of winter, it can be another 2 points of time 6 months apart. Then we look at this star in the summer, it's going to be over here, summer, and look the star in the winter, it is going to be here. And in general, for any star that are in the same plane or in the same solar system, you can find 2 points in the year where that star is a kind of maximum distance from center. And those were the two distances, those were the 2 times of the year that you wanna care most about, because it is more interesting to measure this angle. And I want to be clear, this angle over here is going to be same thing as this angle there. It's symmetric this way, and this is a whatever this angle is going to be, and you could around this is an isosceles triangle. Whatever this distance is from here to here is going to be same as this distance from here to here. And so this angle is going to be equal to that angle, and that angle is going to be that angle, this angle. What I want to do in the next video is think about if we are able to precisely measure these angles, either one of them or both of them. And let me be clear, if this angle is in the night sky is theta and this angle right here is theta, then the difference of here is 2 thetas. So one option, if you want to make sure that the numbers reasonably good, you can measure the total difference, that it is around the center, and then divide by 2. But in the next video, what I want to do is, if you are able to measure the change in apparent or change in angle over here, if you are were to able to measure that, how would be able to use that information to actually figure out the distance to the star. So here we come to an end, and we'll meet in the next topic. I hope the topic name will be the stellar distance using parallax, cosmology, and astronomy. Sorry. And here we came to an end. All the best, and subscribe to the OneMentor. Thank you. All the best.